This video will see about capacitance, the basic definition and basic thing and important points in capacitance. See, you're seeing different types of capacitor on screen. The photo you see, the fixed capacitor is there, mica capacitor. This is mica is a dielectric material, and paper also a dielectric material, paper capacitor. Like that, many are there. And see here, variable capacitor also is there. If you turn this knob, depending on that, you can vary the capacitance. So the capacitors have much importance in electronic industry. When whatever the electronic device you take, without capacitor it doesn't work. Okay, so here basic things in capacitor we'll see, and these are very important in answering assertion and reasoning questions in IIT JEE, any competitive exam. And also while applying the capacitance concept in coming sections, in advanced sections, this is very important. So let us see what is capacitance. So to understand, let us take a conductor, some random shape, and here the capacitance case, if you consider, if you supply some charge to the conductor, then what happens is, see, this is a conductor, you supplied some charge to the conductor. This conductor produces electric field in the surrounding medium. So at any potential, you can supply charge to the conductor. That means what? At that potential, that conductor has ability to hold that charge. After having charge, it produces electric field. What is the effect of it? We'll see. We'll discuss in this video only. So basically, what is the if any capacity of a conductor, if you want to understand it, the capacitance of a conductor is nothing but the ability to hold the charge at a given potential. So different capacitors, conductors, if you take, higher capacitance means it holds more charge at a given potential. Lower capacitance means it holds less magnitude of charge. And one more important is it holds the charge. That is, the capacitance is the ability to hold the charge. And how much charge it has and what is the potential of that conductor, on these factors, the capacitance of conductor does not depend. So basically, the capacitance of a conductor depends on size of it, size, shape, geometrical data, size, shape, and also the medium in which it is present. Which one? Conductor, the surrounding medium. Okay, so the medium in which the conductor is there, and what is its size and what is its shape, on these factors capacitance depends. Okay, that you remember, that is very important point. So capacitance depends on these factors, not on the charge it holds. So the basic thing is, more capacity it has means more charge it holds at a given potential. Okay, here another important point also we'll see, maximum capacity and capacitance of a conductor. So maximum capacity and capacitance of a capacitor, both are not same. Okay, so on what factors this maximum capacity depends? See, the capacitance is the ability to hold the charge at a given potential. The maximum capacity depends on strength of surrounding medium, that is dielectric strength or breakdown strength. So that means what? If the breakdown strength of the dielectric medium is more, the capacity of conductor increases, the maximum capacity increases. If you take weak breakdown strength medium, weak medium, then the maximum capacity decreases. Clear? So the capacitance is just ability to hold charge at a given potential, and the maximum capacity of a given conductor depends on the breakdown strength of the surrounding medium. Okay, so let us see here, in this case, see the diagram. So, in this case, see the diagram. 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 what is happening, what here you just observe, this part has some radius of curvature, on that also some charge is stored, and this is lower radius of curvature it has. So different radius of curvature it has. So the surface charge density is inversely proportional to the radius of curvature of a given that region. If you take uniform body, total radius of curvature is same. So the total uniform body will have same equal charge density. What in this region, the electric field intensity will be more comparative to this region. If you place conductor in dielectric medium, here what happens is, for example, you place a dielectric material in an external electric field. Dielectric material means, for example, you take mica sheet, you take the atom of mica sheet at the center nucleus, and around it, surrounding it, or around it, electric charge, electron cloud will be there. So when you apply electric field to that dielectric substance, that dielectric material, then the positive charge will displace in the field direction and negative charge will be distributed accordingly. So let us assume negative charge is distributed in opposite to the field direction. So what is happening here? A neutral atom is becoming a dipole. This is called dielectric polarization. In detail, we'll discuss in next video. So in this case, when a charged conductor is placed in a dielectric material, at this region, whatever the dipoles, whatever the dielectric material atoms are there, dipoles experiences electric force, and positive charge tries to move in the field direction, that is electric field direction, and negative charge will move in the opposite direction. So it generates dipoles here. Here further, if you supply more charge to that, so the electric field is reached to a maximum value, so that the force generated by this electric field breaks that what we say, that dipole into separate charges. Then what happens is negative charge will goes to the material because it is positively charged, and positive charge moves in the field direction, and slowly the body gets neutralized because negative charge will reach here, but positive charges are moving in the medium as a free charge carriers, so that constitutes current. This current is called leakage current, and this phenomena is called dielectric breakdown. Dielectric breakdown. Okay, this phenomena is called dielectric breakdown. This video very important. The capacitance is, what is the capacitance? It is ability to hold the charge by a conductor. And second point depends on size. See, ability to hold charge by a conductor at a given potential V. And what is the second point? On what factor it depends? Size, shape, and surrounding medium. And third point we discussed capacitance and maximum capacity. So maximum capacity depends on the this maximum capacity purely depends on the strength of surrounding medium. What strength? Dielectric. What strength? Breakdown strength. Dielectric breakdown strength. Okay. And another important point, last point is that you must remember, if surrounding medium has weak weak breakdown strength, the capacitance of the conductor is less. That means what? It stores less charge. The maximum capacitance decreases. If surrounding medium has larger or higher breakdown strengths, then the conductor stores more charge. Okay,